thermodynamics. Thermodynamics is the study of heat and energy transfer, and in these subjects, particularly in this unit, we will discuss some fundamentals of thermodynamics and also some laws of the thermodynamics in our subsequent slides. Some of the learning objectives of this unit is to apply fundamental concepts of thermodynamics to thermodynamic systems, and number 2 is to understand various laws of thermodynamics. And to achieve these learning objectives, we will have to discuss some key words like heat, works, properties of a system, and the system itself we have to study. We have to understand what a system is and also the equilibrium of the system. So first we will try to understand a system. In thermodynamics, a system, that means a thermodynamic system, can be defined as a quantity of fixed mass, or we can say a particular region under investigation. That means if this particular mass or region we want to study, then this particular region or mass will be called a system. And every system has a surrounding, and anything external to the system is called the system surrounding. So the outside is the surrounding, and the surrounding and the system is separated by a common surface, and that common surface or the interface of the system and surrounding is called the system boundary. So this is system boundary and this is system surrounding of the system. The system boundary, in practice, it may be real system boundary or it may be imaginary system boundary. In some cases, for our convenience, we have to imagine a boundary, but in real existence the boundary may not be there. So this type of boundary is also considered as system boundary. And both, if we consider system and the surrounding as a whole, then this whole will be considered as the surrounding as the universe. So this is a system, and this system has a boundary which is called the system boundary, and this boundary is separated. The boundary has separated the system from the surrounding. So system and surrounding and system boundary, and if we consider the both system and the surrounding as one unit, then it will be called the universe. So it is universe. Now in this system, heat may enter into the system, or you can say heat may cross the boundary from surrounding to the system, or heat may cross the boundary from system to the surrounding. Similarly, work may go out of the system or work may enter into the system. If work is going out of the system, that will be called work done by the system, and if work is entering into the system, that will be called work done on the system. So this is called work transfer. Similarly, there may be mass transfer. The mass may enter into the system or mass may go out of the system. So these are called the interactions in a system. Now in some cases, mass transfer takes place. In some cases, heat transfer takes place. In other cases, the work transfer takes place. And again, in some other cases, there may be the combinations or permutations or combinations of these three. And based on this, the heat transfer, work transfer, and mass transfer, the systems are classified as a closed system, open system, and isolated system. Now we'll discuss in details and give some examples of closed system, open system, and isolated system. First, we'll consider a closed system. And let us consider one piston and cylinder arrangement without a valve. So this is an example of an piston and cylinder arrangement. This cylinder and this piston can move to and fro, up and down in this case, and these are system boundaries, system wall or system boundaries, and they enclose some gas. Now, if the piston moves downward, then this gas will be compressed. And if the piston moves, suppose from this position the piston is moving to this position, that means we apply some force F and piston moves a distance of x. So the force into distance moved, that will give you the work done. So that means work is done on the system, and as a result of this work done, the heat may be generated, or you can say the temperature will increase. The temperature of the system will increase because of the compression. That means the heat generated by this way, if this cylinder walls are good conductor, then heat may go out of the system also. That means work transfer, and this work done by this is heat transfer, and this is work done on the system, and this is work transfer. The other way, if you add heat to the system, somehow if you can supply the heat, say this is a conductor and we are heating this arrangement, then heat is supplied to the system. That means heat transfer. And because of this heating process, this mass of gas will develop pressure and temperature. That means due to this pressure, this high pressure will push the piston upwards, and suppose piston moves upward by a distance of d, the work done is equal to force means pressure into area of the cylinder, this is a force, into the distance travel. So this is work done, and in this case this work is done by the system. Work is done by the system. So this is work transfer, this is heat transfer, but no way the mass that is contained within this system boundary can go out of the system, or no fresh mass can enter into the system. That means we can say that the mass transfer in this case is not possible because of this arrangement, but energy transfer in the form of heat and work is possible, as we have seen in this case. So this is an example of energy transfer but no mass transfer. Such a system in which mass transfer is not allowed and energy transfer is allowed is called a closed system. Let us take another example of an open system, which is also called the control volume. In open system, both mass and energy transfer is possible. That means mass transfer possible and energy transfer is also possible. So this is the universe, this is the system and the surrounding. In this system, mass can enter into the system, mass can go out of the system. Similarly, heat can enter into the system and heat may be rejected by the system. Work may be done on the system and also work may be done by the system. So all types of interaction, energy interaction in terms of heat and work and mass interaction is possible. So this type of system is called the open system. A good practical example of this system would be the air compressor. Suppose this is an air compressor. So in an air compressor, air enter into the system, that is mass transfer, and the air is compressed, and this air, compressed air, is taken out of this compressor. That means again mass going out. Now for compressing this air, we have to do some work on the system, that is called the work done on the system. So this is called work input, and as a result of compression the heat will be generated and heat may go out of the system, and that is heat transfer. So in this example, the mass transfer, work transfer and heat transfer are possible. So this air compressor is an example of an open system, practical example.